In this video, we're going to use right triangle trigonometry in another applied context. So suppose a ladder, a 10-foot ladder, is placed against the wall, and then the base of the ladder is pulled away from the wall. So I have an animation of this. So the base of that ladder is pulled away from the wall, but the length of the ladder itself does not change. We're going to let x represent the distance between the wall and the base of the ladder in feet, and y will represent the height of the top of the ladder above the ground in feet. So we'll just play this one more time. The base of the ladder is pulled away from the wall. We have x and y representing certain distances, and then we'll also let theta represent the measure of this interior angle down here in radians. So let's suppose the base of the ladder is 6.5 feet away from the wall. Let's see what we can say about this situation. So let's first draw a diagram of this. So we have the ground here, we've got the wall here, and the ladder right here. And so we know that the base of the ladder is 6.5 feet from the wall. So this distance right here is 6.5 feet. And you should be able to see a right triangle in this situation. So we see a vertical leg right there, a horizontal leg right here, and then hypotenuse right here. We know that the hypotenuse is 10 feet long because the ladder is 10 feet long. And then the length of that horizontal leg is actually 6.5 feet. So we could actually find the length of the vertical leg if we wanted, but we won't worry about that right now. Let's start by deciding what this angle measure theta is. So what is the measure of that interior angle there? So one of the things we know is cosine of theta is going to be equal to the measure of the horizontal side, which is 6.5 feet long, and units of the hypotenuse, which is 10 feet long. Therefore, theta will actually be equal to inverse cosine of 6.5 divided by 10. And this has a value of approximately 0.863. So we can say that this angle measure right here is approximately 0.863 radians. If we wanted to know the slope of this ladder, we now know the angle measure, so we could use the tangent function to determine that slope. So the slope of this ladder, we'll just call this m, is going to be equal to tangent of the measure of that angle, which is about 0.863, and this has a value of approximately 1.169. Therefore, the slope of this ladder is about 1.169. Let's look at a similar situation. We'll now assume that the top of the ladder is 6.5 feet above the ground. So we have a similar situation. We'll draw the ground, we'll draw the wall here, the ladder right there, and now what we know is the top of the ladder is 6.5 feet above the ground. And in this case, we can again draw the same right triangle we had before, well, same orientation, but different side lengths. In this case, we know that the hypotenuse is still 10 feet long, vertical side of that right triangle is 6.5 feet long, and we don't know the horizontal side length. And in this case, we could then say that sine of theta is equal to 6.5 divided by 10, where theta is this interior angle measure there. And therefore, in this situation, theta should be equal to sine inverse of 6.5 divided by 10, which is approximately 0.708 radians. And therefore, in this situation, the radian measure of that angle of interest is about 0.708. In a similar way, we could use that angle measure and the tangent function to determine the slope of the ladder in this situation.